Okay, so today we're going to talk about 3.7 notes. And the first thing we're going to talk about is the degree and how to recognize those by just looking at the graph that's given to us. There is a type of formula that you can think about. And the way to think about that is we can find the degree of the polynomial. It's equal to 1 plus the number of humps. Okay, that might sound a little weird to begin with, but let's look at this very first one. This is a linear function, okay? So I know that all my parent functions range from y equals x squared, y equals x cubed, and so on and so forth. So we should recognize this as one of our parent functions. This is the linear, it's the y equals x. The highest degree on my x is a 1. I can look at that graph and know that for sure. The degree of the polynomial is 1, okay, so 1 plus the number of humps. This is a straight line, so it has 0 humps. Therefore, its highest power is 1. So it would be y equals x to the first. There's always an understood 1 there. We do not have to write it. We can apply that same process with the quadratic. We know that the quadratic is, we used to say all the time, I'm not a square, I'm happy, so a smiley face, y equals x squared. If we follow this same pattern, 1 plus the number of humps. Now what I'm talking about humps is there a max or a min? There would be 1 hump, so plus 1. 1 plus 1 equals 2, so this would be y equals x squared to the second power. This next one, we would do the same thing. 1 plus, let's count the number of humps. There's 1 here and 1 here. I have a max and I have a min. There was 2 of those. 1 plus 2 is 3. So y equals x cubed, and we know that that is a version of what we used to call John Travolta. Okay, so it looks like a cubic. The very next one that we have, we're going to do the same thing. 1 plus, let's count the number of humps. 1, 2, 3. 1 plus 3 equals 4, so this one would be y equals x to the fourth. If we started getting the pattern here, we can probably see that this next one's going to be y equals x to the fifth, but let's just make sure. It's always 1 plus the number of humps. There's a hump here, 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 and here. So I have a total of 4 humps. 1 plus 4 is x to the fifth. So y equals x to the fifth. That is a degree of 5. Degree of 4, degree of 3, degree of 2, degree of 1. All right, so let's look at the end behavior on these. All of our end behavior stems from 2 parent graphs. They either stem from a cubic, which is this one, y equals x cubed, or y equals x squared. All of our graphs are some variation of these 2 parent graphs. Now, y equals x to the third is an odd power. That makes it an odd function. So an odd power is an odd degree or an odd function. When we look over here at y equals x squared, we see squared, 2 is an even, so it's going to be an even power, or it's an even degree. Everything we do is going to be some variation of these. Sorry, I just hit my desk and it's shaking. Okay. Now, there are certain things that we talked about, and we talked about them last year, or last semester, that if at any point in time I throw a negative in front of this, it's going to flip my graph. So starting with the happy to sad, we know that if I throw a negative in front of my function, it goes from being happy to being sad. So we could say that this one is a negative, even. This one over here, or let's just talk about this one up here. This one would be a positive, even. Okay, so meaning that their degrees are both even powers: positive, happy, negative, frowning. Okay, we can do the same thing with what we were talking about with John Travolta. So in this case, this is the parent function, and we know that the parent function, just like over here, is positive. So it's positive, odd, because the degree is 3. 3 is an odd number, 5 is an odd number, 7 is an odd number, 9 is an odd number. Any variation of an odd number is going to be in these quadrants. Going over here to this one has flipped. All we've done is negated it. This is a negative, odd degree. Okay, so let's just kind of talk about this, because I'm sure some of us are like mind blown and we have no idea at this point really what's maybe going on. So let's take a step back and let's look at this. One of the easiest things to think about is, so let's go up here into the corner of your notes. If something is even degree, if it's even, it's going to be going the same direction on both ends. Okay? And what I mean by that is these are even ones. Both of the end results in behavior are both going up. They're both going the same direction. That means it has to be even. If you look down here, both of the end results are going down. It has to be even. It doesn't matter what happens in between, it's still going to be even if they're both pointing the same direction. Now, what's true about the flip side of that is odd degree will be going different directions. So if you look over here at the odd one, I have one going up, one going down. Therefore, it's going in different directions. It has to be an odd degree, whether it is 1, whether it's 3, 5, 7, depending on the number of humps it's got. That'll depend on whether it's odd or even. Looking down here at the negative version, odd, they're going different directions. Okay, so that's the way we can figure out if it's odd or even. The other way we can think about if it's positive or if it's negative. So let's talk about the even ones. So if it's positive, think about our midline. Everything going up on our axis, starting here at the x and going up, would be positive. Okay, so positive we can think of as going up. In reverse, if I start here at the x-axis and I go down, it's going to be negative. So negative is down. Now, our odd degrees are a little bit more tricky, okay? So the way that we can think about those is positive goes from quadrant 1 to 3. Okay, so in case we have forgotten how to number our quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So when I have an odd degree, if I am in 1 and 3, the odd quadrants, I am positive. So quads 1 and 3. So using that same idea, if I was negative, I would be in quadrants 2, and 4. I'll be in the even quadrants. I'll be going, instead of going right and down, I'm going to go left and down. So let's talk about how we would use that in the homework and kind of what that would look like. So on here, it wants us to determine our end behavior. Now, yes, you can graph these. Eventually, the graphing calculators on something like this, I'm not going to let you use the graphing calculators on this. I want you to have this memorized. Okay? So when we look at this, I can automatically look at this and I want to find the highest degree. My highest degree on 1A is 3. Is that odd or even? Well, it is going to be odd. What is the leading coefficient? The leading coefficient is -4. Is that positive or negative? Well, it is negative. So they want to know, identify the end behavior. So the end behavior is going to look like this. It does not matter. I agree that if I was to graph this, there's going to be other humps and bumps and all kinds of different motions going on. But they don't care about that. They only want to know what's going on at the very end. Well, it's odd. It's going to be going in different directions. One's going to be going up and one's going to be going down. And it's negative. So if I look over here, negative goes up in quadrant 2 and down in quadrant 4. That's going to be the end behavior. Now, we have to actually say what that end behavior is. Now that we know how to graph it, we actually have to say what x and y is approaching. Okay, so I'm just going to start and read my graph from left to right. I'm going to tell where x is approaching, and I'm going to talk about where y is approaching. These are on your chart, but that's a lot to memorize. You can look at this graph and know where x is approaching. Okay. Up here on the top, x is approaching. It's going this way, and it's going to just keep going and keep going and keep going and keep going, and that happens to be going to the negative infinity. So my x values, okay, so these are my x values, are going this way. All right, let's look at where the y values are going. My y values are going up, which would be positive infinity. So what we're going to do is we're going to do the same thing over here on this one. We got to know where x is approaching, and we got to know where y is approaching. So looking here, my x just keeps going and going and going this way, which means that x is going to be approaching positive infinity. Where's y going? Well, it's pointing down, so y is going to be going down to negative infinity. Now, there's another way that you can look at this. If this does not make sense by looking at just the graph, I will show you another method. Okay? So come back over here where we wrote our little quadrants 1, 2, 3, and 4. Down here, let's talk about what our x and y values are in each of those quadrants. In quadrant 1, our x values are positive and our y values are positive. If our end behavior is in one of these, x is approaching positive infinity and y is approaching positive infinity. Over here, my x values are going to be negative, my y's are going to be positive. If my end behavior is in this quadrant like it was right here in this one, x is approaching negative infinity, y is approaching positive infinity. Those match up. So down here I have negative, negative. If my end behavior is in this quadrant, it's going to be x is approaching negative infinity and y is approaching negative infinity. So quadrant 4, I have my x's are positive and my y's are negative. If you look at these values, they match identical to the end behavior that we had right here in this first example, 1a. X is approaching positive, y is approaching negative infinity. So if it doesn't make sense to look at the graph, know your values, okay? That's the same place that your end of behavior is going. So let's look at this one right here. Let's look at B. The very first thing they want me to do is find the highest degree. So the highest degree is 6. Is that odd or even? It is even. And then they want to know what the leading coefficient is. So my leading coefficient is positive 1. So it's positive. So I have an even degree. Even means I'm going to be going the same direction. Okay? And since they're both positive, they're happy, they're both going to be pointing up. It doesn't matter what's going on in between. They only want to know what's happening on the ends. So if I use my chart over here, x is approaching negative infinity, y is approaching positive, and over here on the right, I have x is approaching positive infinity and y is approaching positive infinity. So far, so good? Let's go ahead and do another example, okay? So let's do this one right here. Let's do 1a. So 1a, we're going to find the highest power, which is 5, which is odd. 5 is an odd number. The leading coefficient is 2, which is a positive number. So it is an odd positive. Okay, so it's some variation of my cubic. It is odd, so I'm going to be going in different directions, and since it's positive, I'm going from quadrant 1 to quadrant 3. They want to know the end behavior, so I can either look at this chart right here and know that in quadrant 1, x is approaching positive infinity and y is approaching positive infinity. And over here in quadrant 3, x is approaching negative infinity, y is approaching negative infinity. Now, let's go ahead and look at example 2. Example 2 wants me to decide, first of all, are these odd or even? Then they want to know what the degree is. And then they want to know if it's positive or negative. So, first of all, let's just look and see if the arrows are going in the same direction or opposite directions. If they are going opposite, odd. O for opposite, O for odd. If they are going the same, they are even. Okay? So I have opposite directions. If I look here and here, that's opposite direction, so it has to be odd. Let's look at this one. Same directions, even. Now, they want to know if this is a positive or a negative leading coefficient. Well, this one goes from top right to bottom left. Quadrant 1, if this goes to it, keep extending, it's going to go forever, and it's going to end up over here in quadrant 3. So this one has to be positive. Okay, it matches my parent graph. It goes up in the first, down in the left. Let's look at this one, the even one. I went from, if I was positive, I'd be smiling, I'd be happy. But this one's frowning, it's down. So if I'm frowning, I'm sad, which means I am negative. Now, the last thing they want to know is what the degree is. So the way we found the degree, back up here at the top, was we counted 1 plus the number of humps. Okay, so let's look here. I have 1, 2, 3, 4 humps. Don't forget, we always have to add what to it? 1. So what's the degree of this? X to the 5th. It is a degree of 5. It's some variation of x to the 5th. Let's look at this next one. Okay, let's count the humps. We have 1, 2, 3. So I have 3, don't forget, plus the 1. So it is a degree of 4. Makes sense. 4, even, 5, odd. Let's do this next set just to make sure that we kind of have a good idea of what's going on. First thing I look at is if I have odd or even. Well, I'm going in different directions, so I've got to be odd. I'm going in the same direction, so I must be even. Next thing I'm looking at, am I going from right down to left, or am I going left down to right? Well, on this one, I'm going from left to right, therefore I must be negative. Now, on the evens, am I happy or am I sad? Well, looks like I'm smiling. My corners are going up, so this would be positive. Now I need to know the number of humps to find the degree. It's always 1 plus, 1 plus. This one is a little bit tricky here. That's considered a little bit of a hump, and that one's a little bit of a hump. So 1 plus 2 equals 3. So it's a degree of 3. This one has 1, 2, 3. 1 plus 3 is 4. So it is a degree of 4. Okay? So let's look and see if there's much more to do after this. Okay, so what I want you to do for tomorrow, okay, we're going to stop there on the notes. What you're going to do for tomorrow is you are going to do page 1 of 201, okay? So I expect you to do 1 through 22 on that very first page. It's nothing different than what we've been doing. We'll do max and min tomorrow with the calculator when I'm here, and we will just review over this. This should be pretty self-explanatory. You can always stop and rewind this or play this again. I will go ahead and make sure that I also upload the link to Google Classroom. So if you need to look at this on Google Classroom, you can. The other thing you might try is logging into the MyHR, and you can listen to the way they explain it and see if it does help to see it explained maybe a different way. So again, tomorrow you are expected to have all of page 1 of 201 completed.